Hi, I'm Thomas. Welcome to Algebra 2. Today we're looking at vectors, and we're going to work through a problem from the IGCSE paper 0606 from October 2016 regarding relative velocity and interception. We read our scenario. The town of Cambly is 5 kilometers east and p kilometers north of Edwintown, so that the position vector of Cambly from Edwintown is 5,000, 1,000 p meters. Manjit sets out from Edwintown at the same time as Raj sets out from Cambly. Manjit sets out from Edwintown on a bearing of 020 at a speed of 2.5 meters per second, so that her position vector relative to Edwintown after t seconds is given by 2.5t cosine 70 degrees, 2.5t cosine 20 degrees meters. Raj sets out from Cambly on a bearing of 310 degrees at 2 meters per second. Our first part is find the position vector of Raj relative to Edwintown after t seconds. So let's show the position vector from Edwintown to Cambly. Notice that the vector is going right and up, which is indicated with positive values for the x and the y, 5,000, 1,000 p. Now let's look at diagramming Manjit's movement to understand how that diagram gets to the position vector we're given for Manjit, and then we can understand how to create the position vector for Raj. So the vector for Manjit is 20 degrees east of due north with a velocity of 2.5 meters per second. Now looking at the position vector given, we see in the y value 2.5t cosine 20 degrees. That's the vector's position from due north. For the x-axis, we see 2.5t cosine 70 degrees. And to understand where the 70 degrees is coming from, let's draw in a horizontal vector as a reference point. And we can see that the 70 degrees is a reference point from the horizontal axis. So cosine of 70 degrees multiplied by 2.5t represents our change in horizontal position over time. So now let's draw in the vector representing Raj and see if we can use that to find the position vector of Raj relative to Edwintown after t seconds. And let's draw in our horizontal and vertical reference vectors to identify the relevant angles for Raj. And those angles are 40 degrees and 50 degrees. Now notice that Raj isn't starting from Edwintown, Raj is starting from Cambly. So we're going to begin with a position vector from Edwintown to Cambly of 5,000, 1,000 p. And from here we want to add on the change in position, starting with the horizontal position. Notice that our velocity is 2. So following our example for Manjit, we're going to start with 2t, and the angle in reference to the horizontal reference vector is 40 degrees. So for our x position, we have 2t cosine 40 degrees with an important adjustment, which is that we're starting east of Edwintown, moving west, which means that from an x-coordinate standpoint, we're getting closer to Edwintown. Thus, we want a negative to show that the x value is going to be decreasing over time. And now our vertical position. Our vertical position will change by 2 times t times cosine of the angle relative to the vertical reference vector, which is 50 degrees. And so the position vector of Raj relative to Edwintown after t seconds is 5,000, 1,000 p plus negative 2t cosine 40 degrees, 2t cosine 50 degrees. And now we'll go to part 2 of the question. Manjit and Raj meet after t seconds. Find the value of t and of p. Now if we look at the vectors for Manjit and Raj from part 1, we see that they are eventually going to meet or intercept. Thus the reference to this calculation is a calculation of interception. If we think about these vectors in a coordinate plane, the interception is going to be where the two vectors have the same x and y coordinates. So we'll solve for t by setting the position vectors equal to each other. And the position vector for Manjit is 2.5t cosine 70 degrees, 2.5t cosine 20 degrees. Notice that we have an additional variable in the y value of the starting portion of Raj's vector, 1000p. So we'll use the x components to solve for t to begin. 5000 plus minus 2t cosine 40 degrees equals 2.5t cosine 70 degrees. And then with algebra, 5000 equals 2.5t cosine 70 degrees plus 2t cosine 40 degrees. We can factor t out of the right side of the equation and then divide both sides by 2.5 cosine 70 degrees plus 2 cosine 40 degrees equals t. T equals 2095. And now we can use the y components of the vectors to solve for p. 1000p equals 2.5t cosine 20 degrees minus 2t cosine 50 degrees, which is t times 2.5 cosine 20 degrees minus 2 cosine 50 degrees. The t we replace with 2095, and if we divide both sides by 1000, we get our solution for p, which is 2.23. This concludes our lesson on using vectors and relative velocity to solve problems of interception. These are challenging concepts, so be sure to practice with textbook exercises. Thanks for watching, and I'll see you in the next lesson.